David, you want to walk me through the first row? Equation 1, equation 2, equation 3.
That is 0.1330, and then negative 0.2182.
2, 1.
82. I don't know after that. I don't remember matrices at all.
Okay, so if we're looking at equation number 1, there's a coefficient of ACE. So here's ACE, and then there's a coefficient of AD. So there's no coefficient, right, for AB? So let's take a look at this.
Oh, okay, I get it.
Okay, so everybody look up here. Whatever's in this block gets multiplied by AB. Whatever's in this block gets multiplied by AC, and this block gets multiplied by AD. Okay, so what is the coefficient of AB in the equation 1?
0.
There's none, so it's 0. Okay, how about SAC?
And it's 0.1330.
Okay, positive or negative?
Positive.
Okay, and then how about SAD?
Negative 0.2182.
Okay. Okay, Iliad, how about for equation 2? What should be in the, for equation 2, what's the coefficient of AB?
Negative 0.7682.
Okay, and then the coefficient of AC?
Negative 0.8665.
Okay, and the coefficient of AD?
Negative 0.879.
Okay. And then Chris, for equation 3, what's the coefficient of AD?
Negative 0.6402.
6402, negative you said?
Yes.
Okay, next one, AC?
Negative 0.433. 4433.
Okay, and then the coefficient of AD?
Negative 0.4365. I'm sorry, for the second one?
Yeah.
Negative 0.4433.
Okay. All right, and then you have the solutions already. Yeah, Peter?
I think it's 4,905.
Let's just check to see what I have over here. So 0,
Because up top, I think
76,
I think
6402.
you get a mistake.
There's a mistake on here?
Well, I think you meant to write a column for that, maybe?
Okay, so what's the,
For
where's the error?
equation 3 at the very end, 4,900.
Oh,
As opposed to 4,000.
that should be a decimal, right?
Yeah.
Thanks.
No, it shouldn't be. It is written on the board as decimal though.
I think it's a decimal because I'm coming up with kilonewtons. Initially, I calculated it as newtons,
Okay.
4905 newtons, and then I converted it to kilonewtons, so I wasn't dealing with so many
Gotcha.
large numbers.
Okay.
So in here, if my answers came out to be kilonewtons, it would have been a decimal.
Okay.
Okay, so with the 3 by 3, if we have 3 equations, so I don't want you to play around the calculator right now and figure it out. It's going to be a workshop that you can figure out on your own. But if you have a 3-dimensional problem and you have 3 equations and 3 unknowns, can we do what Eric or Evan suggested? Isolate the variable, shove it in. It's going to be a nightmare with a 3D problem, right? With 3 equations, 3 unknowns. So you need to know how to do it on your calculator. So either you could input the 3 equations in your calculator and it'll give you the 3 values, or you can convert those 3 equations to the matrices function and push this in your calculator and it'll give you the solutions. So you have 1 of 2 ways to solve 3 equations with 3 unknowns. And you're going to need to do it with the calculator. Who's in circuits right now? You guys are going to be doing these. When we move on halfway through the semester, you're going to have, in statics, you're going to have 6 equations, 6 unknowns. And in circuits, you're going to have 6 equations, 6 unknowns pretty soon. Have you gotten to 6 equations, 6 unknowns yet? In circuits?
No.
No? But you have.
There's plenty of unknowns.
What?
There's plenty of unknowns in circuits, but
You get to like
we
the
have
end,
enough
don't you?
to
6x6.
Okay, so you're gonna need to know how to do it on your calculator, right? So that's what the purpose of that workshop is. So this workshop, back on your syllabus, so workshop number 3, 3D matrices, you're gonna need to know that, and it'll be important for the exam as well. Yeah, Chris?
For the exam, you want presented with the equations and then matrix form and then the answers.
Ah, good, so Chris is asking me how I want it presented. I definitely want the equations, because the equations are what you have to show me for statics. And then you can just tell me how you found it, you can say calculator. You do not need to write this on the exam, unless you're plugging in matrices. If you're not plugging in matrices and you're just doing 3 equations, 3 unknowns, you only have to show the statics equations. So on the exam, I'm gonna say, this is how I want you to do it. Do the setup, and I'm gonna say, I want given, find, the table, how many unknowns, how many equations you need, how many bodies you're gonna analyze, draw the free body diagrams, set up the statics equations, and then give me the solution. So how you go from the equation to the solution is your own choice. You do not need to set up the matrix on the exam. Okay? So next week after you do, on Tuesday, I'll check in with you to see how many people are doing matrix on the calculator and how many of you are doing 3 equations, 3 unknowns. I'll just find out from you what's more comfortable. Typically in the past, most students do 3 equations, 3 unknowns, or 6 equations, 6 unknowns, rather than putting it in a matrix form. Okay? And JJ, would you try this out and let me know which one works?
Sure.
You don't have to do it now. Okay, let's do some fun problems. We're gonna do pulley problems now. So this is in the packet, it's on page 14. Okay, the first one we're going to do is this one. What did we learn about continuous cables? What's the force in a continuous cable? It's tension, and it's the same, right? As you follow through on that cable, it's all going to be the same tension. So this pulley problem right here has a tension labeled right here. So follow through on that cable and put a T next to everything that's the same cable. Because you know that if it's being pulled with a tension of T, then anywhere along that continuous cable is going to have a tension of T. So how many T's did you find? 2? Okay, so Santiago, so where did you write T? So T here,
Right next to the pulley in B.
okay, so right here, this is T.
Yeah. And then the, right next to it, the other.
Right here,
Yeah.
right. So this cable right here is continuous, so that means that the tension in the cable on this side is T. It's going to be T here and T here. Now, taking a look at pulley B, how about everybody draw a free body diagram of pulley B on the side? We'll draw the pulley. What should I draw on the top of the pulley? I have 2 tensions going up, right? Alright, so I have 2 tensions going up, and then there's a cable going down, right? Matt, what do you think the value of that cable is? Okay, well, think of the sum of the forces in the y equals 0. In order for this pulley to be in static equilibrium, if there's two t's pulling up, what needs to be pulled down? 2t. Does that make sense to everybody? That in order for this pulley to be static, if it's being pulled up by 2t, the bottom cable has to be 2t, otherwise this cable is going to go up or down. Otherwise the pulley is going to go up and down. So what would happen if this t right here, what happens if this is only t? The pulley's going to fly up. What if this is 3t? The pulley's going to fly down. So the only way for it to be in static equilibrium is if 2t's going up, 2t's got to be going down. So we have a 2t here. So Jill, if 2t is here, what is this cable going to be? That's right, why? More, it's a continuous cable, right? If this is 2t, if the cable is experiencing double tension on this side, it's going to experience double tension on that side. And then Santiago, now I want you to draw a free body diagram of the pulley C. We have a 2t going up and a 2t going up. So what's this tension in here going to be? 4t. So how are we going to relate? How is W related to the tension? So the weight is equal to what in the end?
4T.
4t. So this problem, the weight is equal to 4t. Okay, so go back now and look at T and follow through and make sure that you're comfortable with that. Okay, let's go through now. So, this is what was passed. So what's the whole point of using pulleys? What is a pulley considered? Do you remember in physics, a simple machine, right? There was a bunch of different things that are simple machines, pulleys, what else?
Screws, wrench,
Wedges, levers. So what's the big deal about a simple machine?
gives you mechanical advantage.
It gives you a mechanical advantage. So right now, if I had a pulley hanging from the ceiling, and on one side was an engine block, right? And the engine block was connected to a rope, and the rope went around the pulley, and I'm on the other side and I'm pulling it, do I have any mechanical advantage by using this pulley?
Yes.
What?
Okay.
Let's try it again. So we have this big pulley hanging from the ceiling, and the rope comes down, it connects to an engine block, the rope goes up, it goes around the pulley, and I'm on the other side pulling it. Do I have a mechanical advantage?
Not the same.
Not really, except if we talk about friction, right? But if we assume it's frictionless, if that weight of that engine is, give me a realistic number for a weight of an engine, 400 pounds? 400 pounds, I have to pull it 400 pounds. The only way I could get a mechanical advantage is if I'm using a system of pulleys. So in the situation here, we have this weight, right? Let's say that weight, let's say the weight is 100 pounds. How much do I have to pull it at? 25 pounds. I only have to pull 25 pounds, and I'm able to lift that weight that's 100 pounds. Because I put a system of pulleys together to make a mechanical advantage. So that acts as a simple machine. Do you understand what I'm talking about, the example here? Where if I have an engine block, it's connected to a chain, probably more likely than a rope. A chain that goes around the pulley, and I'm pulling down on it, it's the same. If I ignore friction. JJ, were you gonna add something? No. Okay, so let's take a look now at this problem. So you always have to choose on where to start. And it doesn't really matter where you start, but sometimes it's just a little bit easier if you start at a certain point. I started here with T, but I could have started with the weight if I wanted. Let's go backwards on this one. If I started with the weight, let me write with a different pen. If I started with the weight of W, right here, and the weight is coming down here, what would these have been? Isadora. So if I have this, I'm just going to keep using variables rather than using the numbers. If I have this as called W, and I was working from this end rather than that end, what would this cable, what would the tension in this cable be?
1/2 W.
W over 2, W over 2. Okay? Okay, then I get up to here, and then what would these be equal to?
W over 4.
W over 4, W over 4, and then if this is W over 4, this is W over 4 too, and I would find that T is equal to W over 4. Take a look at it for a little bit backwards. So if we started with W, we would divide by 2. Why am I dividing it by 2? How do I know that the cables have the same tension? Because it's a continuous cable. So if I have a weight coming down here, I know that these two together have to be equal to the weight. And since it's a continuous cable, I know the load in this is the same in both, so it's both got to be W over 2. Then when I have W over 2, when I look at that pulley V, if W2 is going down, the weight going up has to be W over 2, and it's split evenly because it's the same cable, so it's W over 4. So you could go each way. You could go left to right or right to left.
Going backwards.
Okay, so you choose which way you prefer to go. So let's take a look at this. So where can we start? We could either start at P, or we could start at W. So where do you want to start? It looks to me that P is a little less complicated because there's only 2 cables rather than 3. So how would we start at P? Okay, Evan, let's draw a free body diagram of pulley C. I have P coming down, and I have 2 cables going up, right? So what is the cable equal to? Right, P over 2. So P over 2, P over 2. Anybody need clarification on that? We have P going down, each of these has to be P over 2. And then follow that P over 2 through, and then find out what the correlation is between P and W.